Hello, Algebra 2. Welcome back. This is 6.6. This is going to be the last one that we do in Chapter 6. So I think your assignment is just 9 questions. This tells you a little bit more complicated what this is. Tried to cut that down to as minimum as I can. If you want more, you can always go to the Dynamic Learning edition on your big ideas and go down to the exercises and do some more and try them out. Test them out in case you're really bored. But for now, we will go with what we have here. So 6.6, solving exponential and logarithmic equations. Of course, a logarithm undoes exponentials, exponentials undoes logarithm. How does that work, though? I'd love to get into some more of the story problems and stuff like that, but we won't do it right now. The main thing as we go through these is knowing when do you have to use those inverse operations and when can you just set parts equal to each other. So if we have e to the x, something like this, e to the x equals 2. Of course, we can use a graphing calculator to help us with that, but that is a resource, not the way it needs to be done at times. E to the x equals 2. So you notice how we have an exponential function on one side, and we have a constant on the other side. When we have something like this, we will need to use logarithms. So we need to have the mindset that, think of when I have x plus 2 equals 10, okay? We know naturally, we're like, okay, that's going to be 8. But how we solve it officially is we have to subtract 2 from both sides. There's an addition sign. The inverse of addition is subtraction. This is an exponential function. The inverse of an exponential function is a logarithmic function, okay? So just like we subtracted 2 from both sides over here, we can take the log of both sides. So the log of e to the x equals the log of 2. Now again, I'm using natural log because we have an e. Whenever you have Euler's number, use natural log. Okay, now I have a frog. The frog jumps over the log. So x times the natural log of e equals the natural log of 2. Well, we know the natural log of e, that's base e of e, that's the same thing, that equals 1. So natural log equations are pretty nice because you get x times 1, which is x. X is the natural log of 2. There's your exact answer. That would be approximately natural log of 2.6931. 0.6931. Okay? So understanding, when you have an exponential function, you take the log of both sides and you cancel parts off and they get done with like that. If you are good with converting exponential to logarithmic equations, you can probably jump straight to this. If e to the x equals 2, then your base is e, so natural log base e of 2 should equal x. So you can kind of, if you're in an exponential function, you can convert it to a logarithmic function. This is a logarithmic function. We want to convert it to an exponential function. So we say, okay, this is a logarithm. The inverse of a logarithm is an exponential. So I'm going to say e to the natural log of x equals e to the negative first. So you see the e in the natural log, a base e. This equals x. Okay, so this part right here equals x. If you see that, that is x. So x equals e to the negative first. E to the negative first is about 0.3679. Okay, so the rule here is if you have a base and it's raised to something with the same base. So if I have x raised to the log base x of a, that's going to equal a. X raised to the log base x of a, that's going to equal a. So e raised to the log base e of x is going to equal x. Okay, this one, a little common sense. You see how you have different bases? X has to equal 0 in this case, because the only way to have 2 to a number equaling 3 to a number is for that number to equal 0. Okay, so that would be graph A if you're looking down here. So x has to equal 0, and then the values would be 1. Log base 4 of x equals 1. Okay, so again, a logarithmic function and a constant. So we have a logarithmic function and a constant just like what we had above it. So now I'm not going to use e as my base, I'm going to use 4 as my base. So 4 to the log base 4 of x equals 4 to the first power. Okay, so that part went there, that 1 went there. So 4 to the log base 4 of x is just going to be x, so x equals 4. Okay, 4 to the first power equals x. 4 to the first power equals x. So again, logarithmic and a constant. So our base is 5, so I'm going to say 5 to the log base 5 of x, there's that side right there, equals 5 to the 1/2 power. So 5 to the log base 5 of x is x, so x equals 5 to the 1/2 power, that is the square root of 5, which is about 2.2361. 2.2361. Okay, 4 to the x equals 2, so exponential and a constant, we're going to take the log of both sides. Log of 4 to the x equals the log of 2. Make your frog jump the log. So x times the log of 4 equals the log of 2. And now how you finish it is you're actually going to divide both sides by the log of 4. So x equals the log of 2 divided by the log of 4. You do not reduce 2 over 4. Remember, it's the log of 2 divided by the log of 4. Again, I'm using common log. You can use a natural log. Log of 2 divided by the log of 4, which is 1/2. Okay, cool. Okay, so that's those. Let's keep going with that. We won't cover the bottom of page. No, let's keep moving. Okay, so sometimes when you have exponentials on both sides, it gets a little bit easier because you can set the exponents equal to each other. So what they're saying here is I have an exponential equaling an exponential, and I have the same base number. And that's going to be important here, getting the same base number. So if you have that, then the exponents have to equal what they have up there. So same base, 3 to the x equals 3 to the 5, so x has to equal 5. If I have 5 to the x plus 2 equals 5 to the 2x minus 1, well, that means I have the same base, two exponential functions, x plus 2, the exponents have to be equal. So the exponents equal each other. So x plus 2 equals 2x minus 1 minus the x over, so x equals 3. Minus the x, add the 1. So x equals 3 in that case. 3 plus 2 is 5, 2 times 3 minus 1 is also 5. Okay, so if you have two exponential functions and they have the same base, you can set the exponents equal to each other. Now that same base is going to be a little bit trickier, what we need to do on some of these. Same thing happens with logarithms. So I have a log function equaling a log function. And again, we have to have the same base. So if log base 2 of x equals log base 2 of 7, then x has to equal 7. So if I have log base 3 of x minus 4, and that equals log base 3 of 3x minus 12. No, it's not minus 12. Let's go minus 10. So I have two log functions. I have the same base. So x minus 4 equals 3x minus 10. So 2x minus 10 equals negative 4. 6 equals 2x. So again, x equals 3. Ooh, sorry. Okay, let's go back through that. So I have two log functions, and they have the same base. So x has to equal 7, because the two parts have to equal each other. So log base 3 of x minus 4 has to equal log base 3 of 3x minus 10. So I have two log functions. It's not just a log on a single side like what we saw at the beginning. I have the same base of 3, so x minus 4 has to equal 3x minus 10. So I minus the x over, add the 10 over, divide by 2, I got x equals 3. So where this shows up is like this, is back on page 180. 16 to the x equals 2. We can use the logarithms to still figure that out. Okay, but what about this one? 2 to the x equals 4 to the 2x plus 1. I have two exponential functions, and I have different bases. But the 4 you can rewrite as 2 squared. So you can rewrite this 4 as 2 squared. So you get 2 to the x equals 2 squared to the 2x plus 1. Now we're getting to have the same base. These up here you have to multiply. So 2 to the x equals 2 to the 4x plus 2. So 2 times 2x plus 1 is 4x plus 2. Now you have two exponential functions with the same base. So x equals 4x plus 2. Negative 3x equals 2. So x equals negative 2/3. Okay. All right, let's go work on page 182. And that will be it. We'll work on these. We'll do 183 now. Okay, so number 1, 5 to the 2x plus 1 equals 5 to the 5x minus 8. I have two exponential functions. I have the same base number. So that means I can say, okay, 2x plus 4 equals 5x minus 8, and solve from there. So minus that over, add that over, so 12 equals 3x, x equals 4. Again, you can plug it in, check it out. 2 times 4 is 8, 8 plus 4 is 12, so that's a 12. 5 times 4 is 20, 20 minus 8 is 12. Okay, number 2, we have two exponential functions. But we have different bases. Now, I will tell you, you can take the log of both sides. That's going to be a pretty long process at this point. I'm not going to take you through that because we can get the same base numbers. If you want to know, let me know, or there's videos online. I can send you another video as well if you want to know that, just for that one. So 4 to the 2x minus 1. You notice you have a 4 and an 8. Both of those have a common base of 2. 4 can be written as 2 squared times 2x minus 1. 8 can be written as 2 cubed times x plus 2, raised to x plus 2. So multiply these through, distribute that. So 2 to the 4x minus 2 has to equal 2 to the 3x plus 6. Make sure you distribute that exponent to both parts, the x and the 2. This 2 goes to the 2x and the 1. Okay, so now you have the same basis, so we take our exponents equal to each other. 4x minus 2 equals 3x plus 6. Solve it, x equals 8. Okay, here, 3 to the x plus 3 equals 5. This is an exponential equaling a constant. So we're going to take the log of both sides. This is an exponential. The inverse is a log. Now the log I use, I'm just going to use a common logarithm. So log base 3 of x plus 3 equals log of 5. Not base 3. So log of 3 to the x plus 3 equals log of 5. This whole thing up here is your frog. So it looks like x plus 3 times the log of 3 equals the log of 5. So the whole exponent, the x plus 3, is what you have to take over. Do not distribute through that. If you would, you'd get x log 3 times 3 log 3, but that's going to create a little bit more work. We're just going to divide by the log of 3 here. So x plus 3 equals log of 5 divided by log of 3. And then you minus the 3 over. So you say, okay, I'm going to minus 3. That goes away. So x is the log of 5 divided by the log of 3 minus 3. So log of 5, close the parenthesis, divided by the log of 3, close the parenthesis, minus 3. So x is approximately negative 1.5. Let me see, they say round to the thousandths on these sort of questions, round to the thousandths. So tenths, hundredths, thousandths, that would be 3 decimal places. Okay, number 4. Looks kind of scary, but again, you see a 5 and you see a 25. Those can be rewritten with a base of 5. 1/5, that's a reciprocal, so 5 to the negative 1 to the 3x minus 2 equals 5 squared to the x to the 1/2 power. That is the square root, is the 1/2 power. So 3 exponents in that case. So distribute, we get 5 to the negative 3x plus 2 equals 5 to the 2 times x times a half would be 1x. 2 times a half is 1. So negative 3x plus 2 equals x. 2 equals 4x, so x would equal a half in this case. Okay, again, that first step is kind of the trickiest, figuring that out, and then from there it's just properties of the exponents. Number 12, exponential function and a constant. Okay, so we're not going to do a common base like we want here. We're just going to divide by 12 to start with. So 500 divided by 12, and we get a decimal. Okay, so that is 41 2/3, or 125 over 3. We're going to keep it like that. So e to the 1 minus x equals 125 over 3. Don't round that decimal. Don't round until the end. Okay, because you type that decimal into the calculator, it's going to be eventually off if you just round this and you have to round it later. Okay, exponential function here, we're going to take the log of both sides. Now we have an e, so which log do we want to use? And that is the natural log. So we take the natural log of both sides. The frog jumps over the log. 1 minus x times the natural log of e equals natural log of 125 over 3. So this is why we use the natural log of e. The natural log of e is 1, so that goes to 1. That's what that arrow means. It goes to 1, that's 1. It's basically gone. So 1 minus x equals the natural log of 125 over 3. So x, you move some things around, move the x over, and then bring the natural log over here. X would equal 1 minus the natural log of 125 over 3. So 1 minus the natural log of 125 over 3. So we get x to be approximately negative 2.729. That's a bad approximation. Negative 2.729. Okay. Same sort of thing here. We want to isolate this. We want to get that by itself. So I'm going to add the 14 over. 11 plus 14, that gives me 25. And then I'm going to divide by 3. So I get 3 e to the x equals 25, so I'm going to divide by 3. So e to the x equals 25/3. Natural log both sides, or convert it to logarithmic form. So I get natural log of e to the x equals natural log of 25 over 3. Frog jump the log. X times the natural log of e equals natural log of 25 over 3. Natural log of e is 1, so x equals natural log of 25 over 3. So x is approximately 2.120. Okay, so those are all the different types of exponential functions. Logarithmic functions. Okay, 5 more examples. Here we go. So, a log and a constant. Okay, so we're going to raise both sides with a base of 3. So 3 squared equals 3 to the log base 3 of 4x. Okay, we use 3 because of that 3 right there. So 9 equals this part up here, since those are the same bases, 4x, so x equals 9/4. Okay. Here, natural log, you have a log and you have a log. They have the same base. So you just say, okay, x squared plus 3 equals 4. So x squared equals 1. Take the square root of both sides, you get a plus or minus 1. Both of those would work in there. You can put a 1 in there or a negative 1 in there. You get 2 answers. A lot of times you want to check your answers with this, though. Okay, log base 8, we have a log equaling a constant. So we have a log and a constant. So I want to say 8 to the log base 8 of x squared minus 5 equals 8 to the 2/3. Okay, you're going to start seeing some shortcuts here, which are definitely okay to take. So 8 to the log base 8 of that is going to be x squared minus 5. 8 to the 2/3, that is the cube root of 8 squared, that is going to be 4. So x squared equals 9, x is going to be a plus or minus 3. Plus or minus 3. Okay, here you see we have 3 logarithms. You need to condense this before we do anything. Condense. Condense before we do anything. So this is being added. This is going to be the natural log of x squared plus 2x, and that equals the natural log of x plus 6. So now we have logs on both sides, a log and a log, same base. X squared plus 2x equals x plus 6. Oh, get it all on the same side. We get a quadratic. We get to use some factoring or quadratic formula. Completing the square, whatever you want to do. So minus the x over minus the x, bring the 6 over 2. So x squared plus x minus 6 equals 0. So that factors what multiplies the negative 6 and adds to 1 would be a positive 3 and a negative 2. So the two answers we get here are negative 3 and 2. We didn't talk about it a whole lot, but we saw it. The domain for logarithmic functions is all real numbers, all positive numbers. Okay? So for logarithmic functions, your domain, x has to be greater than or equal to, greater than 0. So when you have this one up here, you have the log of x. Well, x can't be a negative 3 because the log of negative 3 is undefined. So that's what we call the extraneous root, and we're just going to keep that one. That's your only answer. This one right here, remember, that's called the extraneous root. It's one that shows up in your work, but it is not one of your solutions. Okay, that's extraneous root. We did not have that up here because when you plug a negative 1 in, you end up with a 4 at the end. In the parenthesis, you end up with a positive 4. Okay, so that one was okay to have a negative. It's not just any negative gets thrown out, but it's any negative when you plug it in, and it's still a log of a negative. Okay? X plus 5 minus x minus 2 equals 3. So, okay, so we need to condense this again. Again, we have a minus sign, so this is log base 2. This is going to be x plus 5 over x minus 2 equals 3. We have a log on a single side. Converting it to exponential form would work. What we've been doing is taking both sides and raising it to the second, or 2 to that power, base of 2 here. So 2 cubed. So on this side, that all is gone essentially. You just get x plus 5 over x minus 2 equals 2 cubed, which is 8. Multiply that to that side, so x plus 5 equals 8 times x minus 2. And let's go from there. X plus 5 equals 8x minus 16. So 7x equals 21. You get x equals 3. Check it. 3 plus 5 is 8. That's positive. 3 minus 2 is 1. That's positive. Okay? So that should work. Okay. Again, you have about 6 questions. They cover all of this sort of stuff. Go back and rewatch, re-listen to whatever you need to. Let me know what questions you have, and we'll see you soon. Good luck. Thinking of you, praying for you all. Miss you. Have a good day.